To help understand this concept, let's look at an example and try calculating the molecular formula of that compound, shall we? The question says the combustion analysis of an organic compound shows that it contains 65.44% carbon, 5.50% hydrogen and 29.06% oxygen. What is its empirical formula? If the molecular mass of this compound is 110.15 gram per mole, solve for its molecular formula. We can clearly see that there are two parts to this question, right? The first is to calculate the empirical formula and the second is to calculate the molecular formula. Let's begin to calculate each one step by step. The very first step is to find out the percentage composition of each element. Luckily, that is already given to us in this question. So, what are we going to do? We are simply going to divide it by the atomic mass of that element. That will give us the number of gram atoms of each element, which is the second step to follow, isn't it? To find the number of gram atoms of carbon, we will use number of gram atoms equals percentage composition given divided by atomic mass. After inserting the values, we get 65.44 divided by 12. That will give us 5.45 gram atoms of carbon. In a similar way, we will find the number of gram atoms of hydrogen. Number of gram atoms equals percentage composition given divided by atomic mass. After putting the values, we get 5.50 divided by 1.008. That will give us 5.46 gram atoms of hydrogen. Next, we have to find the number of gram atoms of oxygen. So, number of gram atoms equals percentage composition given divided by atomic mass. By putting the values, we get 29.06 divided by 16. That will give us 1.82 gram atoms of oxygen. Okay? Now, guys, after this calculation, can you recall what is the third step? Yes, that is right, to find out the atomic ratio. And how will we find that out? Well, we will obtain it by simply dividing the number of gram atoms of each element by the smallest number of gram atoms. Here, we can see that oxygen has the smallest value for that, which is 1.82. So, to calculate the atomic ratio of carbon, we use this formula. Atomic ratio is equal to number of gram atoms divided by smallest number of gram atoms. On inserting the values, it gives simplest atomic ratio of carbon, 5.45 divided by 1.82 equals 3. For hydrogen, we use this formula. Atomic ratio equals the number of gram atoms divided by the smallest number of gram atoms. On inserting the values, it gives simplest atomic ratio of hydrogen, 5.46 divided by 1.82 equals 3. For oxygen, we use this formula again. Atomic ratio equals the number of gram atoms divided by the smallest number of gram atoms. On inserting the values, it gives simplest atomic ratio of oxygen, 1.82 divided by 1.82 equals 1. Now, if we write it as a ratio, we will have C is to H is to O, 3 is to 3 is to 1. Hence, the empirical formula of this compound becomes C3H3O. With this, we have successfully solved the first part of this question.